This is Mission Control Houston. Let's go down now to the Marshall Space Flight Center in Huntsville, Alabama, and talk with Lori Meggs. Lori, typically we wouldn't be talking about a printer heading up to the space station, but we hear that this one may be a little bit different and special.
That's right, Josh. It's not your average printer. This is a 3D printer that could be used on space station where NASA astronauts might not have to wait on resupply spacecraft to get their supplies. They may be actually able to build something right there. Joining me now is Nikki Werkheiser, and she is the 3D print project manager here at Marshall. Nikki, first of all, tell us what 3D printing is all about.
Hi, Lori. Happy to. Thank you for having me. 3D printing, a 3D printer will extrude plastic, metals, or other materials to build layer on top of layer to create a three-dimensional object. So you might be able to print all sorts of tools, spare parts, things like that.
So it kind of sounds like the Star Trek replicator, right?
Absolutely. We get that a lot, and it is the first step toward that.
Tell us how it all works.
Okay, the 3D printer that we're going to fly in space station will actually be the first ever 3D printer in space. There are tons of printers many people have heard about on the ground. As a matter of fact, my 9 and 11-year-old daughters are asking for one for Christmas. And they have them at Staples and places like that, and you can create all kinds of things with them. But the one that we're looking at for microgravity, of course, we want to build space parts. So the design optimization is very important. As we all know, in space, you have to wait for, as you mentioned, the resupply ships if you need a spare part, or you have to fly a lot of spares up, which take considerable mass and which cost money. Also, things break, and things do actually get lost. We've been on space station for quite a while, and things get sucked into corners and crevices.
No.
Yes, it happens. And on top of that, there are unique type of things that we could do if we had a capability to build in space. For example, CubeSats. Many people have heard about these small CubeSats, and with the onset of nanosat technologies that we have, these are used for all sorts of things in academia, commercial, and you actually can deploy them from the space station. If we were able to print these on orbit, the crew could assemble them and deploy them from station. You can do all sorts of unique structures and just an abundance of different types of experiments.
So this one was built here at Marshall?
Yeah, this one was printed here, and this is just kind of the case of one. It's got some electronics that go inside, and you deploy from station.
So how long does it take to build something like that?
Something like this would actually only probably take an hour, hour and a half. And then you also have things like this. It looks pretty non-assuming. It looks pretty simple. You could print this probably in 15 to 20 minutes. We would just upload a CAD drawing to the printer on station. But what this is actually is MSG, an extraction tool that they did not have on orbit. And actually MSG was down for around 6 months waiting on a resupply ship to bring this up. This is something with the 3D printer capability that we could have actually printed, had on orbit within 30, 45 minutes, able to go.
Wow, what else do we see here that
We've got some other just fun things. Of course, people think of crew tools and wrenches. We've got a metal one here too, and we're starting with plastics for this first printer, but we will be moving to metals and other types of materials. We've got things like, you can imagine, different size sample containers. You can also do interactive.
Oh,
sorry about that. That wouldn't happen in space. It would float away. So you have interactive parts like this that can move. You can do complex parts as well with unique structures.
So tell us about the unit that is actually going to station.
So we're working with the company Made in Space. They're actually located at Ames Research Center, and the project is led here out of Marshall Space Flight Center. It's a really good interaction between this commercial company, whose business model is to create a commercial additive manufacturing 3D printing facility on space station. This is the first step. It is a technology demonstration. It will operate inside the microgravity science glove box. And NASA has been providing the discipline expertise and the expertise in terms of taking a printer that you would use on the ground, which Made in Space are absolute experts on that, as well as designing for space, and making sure that we can verify that for microgravity, the physics of microgravity, as well as the safety and operational constraints in the controlled environment of space station.
And this is also critical, being able to replace parts like this on orbit for future long duration.
Absolutely. The big thing about this is for space station even, it will decrease risk, decrease cost, and increase efficiency. But for longer term missions, for space exploration, this is absolutely a critical technology.
And talk about the ones that we have here on Earth. Will this technology make them better?
Absolutely. There's a lot of applications. We talked to several of our industry partners, as well as academia, even international partners on the ground here. This is an area that has exploded in the last few years. It's been being used in an abundance. So the lessons learned from the microgravity application could actually apply to things on the Earth, especially when you think of things such as maybe the Army. Maybe you have folks out in the field in a remote area, and they have the same type of problems we have in space. Things break and you're remote. You can also think of things like submarines or even just remote regions. Also commercial growth. So in this smaller size and form and function that you get from the printer, you could absolutely apply that to Earth applications.
So we've seen the video of the printer and work with that, but how big is this unit? I mean,
so this is kind of cool. I don't know if you can see it here, but this is actually, we printed a model of the 3D printer. This first printer will be a technology demonstration, so it's a little smaller because we fit it inside of the microgravity science glove box on Space Station. So the crew will actually put their hands inside of the glove box to operate the experiment. We're getting a lot of materials data, and ultimately what this will demonstrate is that the objects that we print in space are equitable quality to those that we print on the ground, that there are no difference in the way that the printing takes place in the physics and the material quality. Made in Space has already done a series of parabolic flights on the KC-135, affectionately known as the Vomit Comet, and they've had excellent results. Everything has shown that it is equitable to Earth, but you get the short spurts of microgravity, and we want to be able to generate full products on orbit.
I'm sure astronauts are excited about this, so
Yes.
Tell me when we'll see this on station.
And we will see this next fall. We'll be launching on SpaceX 5, and we're actually working with the astronaut office now. We already have a set of tools and things that they've picked out and said, hey, can you provide this for us? And we're working toward that now.
Very exciting stuff. Can't wait to see it. Maybe you can build me something a little bit later on today.
Absolutely. We've had a lot of fun with this. Thank you, Lori.
Nikki, so much. And let's take a live look into the Payload Operations Integration Center. Busy at work today, setting up some experiments. SLAM-D, they're working with the crew on station today to get that working, and they'll be busy all day long and all week long. That'll do it for us here in the Payload Operations Integration Center. Now back to you, Josh, at Mission Control in Houston.
All right, thank you, Lori. That 3D printer could change the way we do business here on board the International Space Station, make it quite a bit easier for the crews on board the space station and us here on the ground to get supplies to them. So we thank you for that.